So here we're going to talk about the project of multivariate time series analysis. So first I imported all the dependencies and then I read the data and I thought it would be a good idea to show the correlation between different variables because we're trying to make a prediction of this one based on all of these. And it turned out, yeah, it looks okay. They're either very highly correlated or negatively correlated, so it just has to have like a relationship, except for these which hovers around like okay values. But yeah, this is probably a good idea. So here I made a sliding window of 24 hours, which is one set of data to predict the next temperature. And this is going to produce a time series data, and I parse the data according to the dates and time as specified in the instructions. And then it turned out that some of the label sets were missing values. So I appended, because to match whatever was in the X trend and the Y trend, so I concatenated whatever was at the beginning of the data sets, which would match nature, because then nature would just go back to from the end of the year to the temperature at the beginning of the year, obviously. And then I scaled everything between 0 and 1 for all of them. And then I have to remember to like reshape the things I'm gonna feed to the recurrent net from 2-dimensional to 3-dimensional. And then I built this combination network of convolution followed by a few layers of GRU. I found this was the one that produced the best results, and the trick was to remember to use dropout at all the layers because of how much layers it has. It overfits really quickly. And then so we end up with this loss function that hovers around 0.02 for the test set, which is what is most important, I think, for making accurate prediction. And yeah, it doesn't really change that much over time. So we have predicted the X test. Remember to scale it back and then submitted it to reformat it back to like for submission. And then so I was also playing around with a stack LSTM, and this one's got 9 layers. I also use regularization here of like L2 regularization, and then here we can see the trending history, and you can see it's still around 0.02 ish. That's like the best it can do. So if we graph it, it's kind of similar, except it's a little more consistent actually. So maybe this one is better, but this one takes longer to run. So I guess that's the trade-off. And that's it. Thank you.